Today we're talking about quadratic functions in intercept form and transformations of quadratic functions in factored form. So example 2 says graph h of x is equal to negative x times the quantity x minus 4 and compare it to the parent function. Calculate the given information. So the first thing we have to do is calculate the x-intercepts. And the x-intercepts come from the zero product property. And so what the zero product property says is there are two products in a quadratic. So we have x minus or negative x there, and we have x minus 4 there. So each one of those, if they're equal to 0, then those are going to be the zeros. So in this case, we're going to set each of those equal to 0. X or negative x is equal to 0. We divide by negative 1 to get x by itself, and we get x is equal to 0. So that is going to be one of the zeros. That's going to tell us that x is equal to 0. If x is equal to 0, y also has to be equal to 0. The other one that we have is x minus 4. So we have x minus 4 is equal to 0. So we add 4 to both sides to get x by itself. X is equal to 4. And so what that tells us is if x is equal to 4, then y is equal to 0. So if I substitute 4 into this equation, 4 minus 4, that becomes 0. 0 times negative x is still 0, so the y value is 0. So I have 2 points now. I have the point 0, 0, and I have the point 4, 0. So we have 5, negative 5, 5, and negative 5. So 4, 0. 1, 2, 3, 4. Now, the line of symmetry is the average between the 2 points, and we can count it. We can say 1, 2, 3, 4. 4 divided by 2 is 2, so the line of symmetry is going to be right here. Or we can calculate it from our two values that we calculated here. So we know one x is 0. We know another x is 4. So 0 plus 4 is equal to 4 divided by 2. So in this case, our line of symmetry is at x equals 2. So we can graph our line of symmetry at x equals 2. So that's our line of symmetry there. Minimum or maximum value. So in this case, our a value is equal to negative 1 because there's a negative in front of the equation here. So because our a value is negative, I know that my parabola is going to open down like this. And so that means that there's no basement. These keep going down forever, but there is a top. So in this case, I'm going to try to find a max value. And the way that we find the max value is we take the line of symmetry, because the vertex and the line of symmetry are on the same x value, and we substitute that into the original equation. So we have the equation h of x equals negative x times the quantity x minus 4, and we're going to substitute our line of symmetry into that. So we're going to substitute the 2 into all the x values. So the function h evaluated at 2 is equal to negative times 2 is equal to negative 2. 2 minus 4 is equal to negative 4, or excuse me, negative 2. 2 minus 4 is equal to negative 2. Negative 2 times negative 2 is equal to 4. So the function evaluated at 2 is equal to positive 4. So that tells us that we have a vertex at the point 2, 4. That's the vertex. So at 2, then we go up 4, and that should be enough. We have 3 points there. We have the vertex. We have our 2 x-intercepts, and that will be enough to graph a good graph for this parabola. Then we can take a look and see what that looks like. And we can see that we have the point 2, 4, 0, 0, and 4, 0.